All right, so we're live. I hope everyone is staying safe. We're still not out of the coronavirus thing yet, so I hope everyone's staying home, staying safe. So let's get started with our weekly live stream on different aspects of application security. Today's live stream is going to be something that I saw about 2 weeks ago, and I was completely blown away by this. And I want to talk about this in this live stream, and I want to do a little bit of live code. Before that, let's get a few things out of the way. Of course, uh, my name is Abhay. I'm the founder of V45. I do a lot of I handle technology for V45, which means I end up doing a lot of building and breaking of security. I'm involved in a bunch of open source as well as do a lot of architecture for our commercial projects as well. I do a lot of training at various events. In fact, now with Black Hat becoming a virtual event in the US, you're going to see us deliver two trainings at Black Hat. So if you're interested in attending one of our Black Hat programs, we're doing the Kubernetes Masterclass and the DevSecOps Masterclass. So if you want to get registered, I think they should be announcing something around that pretty soon. In fact, yesterday I also got another piece of good news that we're also going to be at Black Hat EU. Now, I don't know whether Black Hat EU is actually going to be happening in person, but it's definitely going to be happening as a virtual event if it's not happening in person. So we're also going to be at Black Hat EU. So I look forward to seeing all of you Londoners and, of course, whoever is part of Black Hat EU to see you in November, whenever that's going to be. So before we go ahead, a few announcements around virtual training. As always, we have some amazing virtual training offerings. We're seeing a lot of traction around this. We have the DevSecOps Masterclass on 1st July, and you have $200 off on that class. So definitely want to go to store.v45.com, get registered. We also have the containers, Kubernetes, and serverless class, which used to be $1,650. It's actually $499 till June 5th. So you definitely want to go to store.v45.com and register right now because these are some amazing offers that you have. So I am just going to quickly push those banners up on screen so that everyone who needs it can just go and check it out. And with that, we're going to get started with our content for today. Now, today's topic is going to be static analysis. Right now, you might be thinking, oh, okay, ho hum, who's interested in static analysis? Why are you talking about static analysis? Isn't static analysis really old and really boring? Uh, yes, I mean, to a certain extent, static analysis is old and it's boring. And if you've had the misfortune of dealing with certain tools, then static analysis is also riddled with false positives. So it's never a pleasant experience to deal with a mountain of false positives with extremely high noise versus signal ratio. So definitely static analysis is something that a lot of us take with a pinch of salt. In fact, if you speak to IaaS practitioners or DaaS practitioners, they would say that static analysis is complete. It's a complete waste of your time. In fact, they would just trash it right out the door. And I'm not so skeptical about static analysis. I still do find that there are some tools of value that you can do a great job of static analysis with. But 2 weeks ago, I spoke at the OWASP Seattle chapter, and one of the other speakers in that event was part of a team that had built this open source static analysis tool that was phenomenal. I was just blown away by that, and I want to talk about that a little bit. And I want to give you a little bit of perspective before I start talking about that tool itself. Right. So when it comes to static analysis, you really are looking at three types of tools, right? So we're looking at your mostly commercial tools, which are multi-language, multi-platform. They at least they claim, a lot of them claim that they can do any language. Of course, they do have certain strengths and weaknesses, but their essential claim is that, hey, you throw any language at us, we will be able to do it. Now, some of that is, of course, BS, because in some cases they don't have the capability to do that, and in some cases they just claim to do that. So I would say that in some cases it's definitely a little bit of BS, a little bit of sales, but they have their place, especially for very large companies. You don't want in many cases they don't want to have too many tools and too many different teams, so they typically go with these kind of tools. And of course, these kind of tools cost a bit of money too, so probably come with a lot of support as well. So now when you typically deal with these tools, they're multi-language platform, they use either syntax tree type of representations or regex based representations. So depending upon which language they're strong in. So for instance, regex essentially, as most of you know, is regular expression, right? So you write a regular expression, you try and find it in your code, and you essentially call that out as a flaw. Now, a regex is okay, it's definitely easy to work with, but it is also fraught with a lot of false positives, right? Because you have code comments, you have different ways, you have aliasing of libraries. As a result, regexes might fail quite horribly. So regexes are okay, but they're definitely low barrier of entry from a skill standpoint, but they're definitely not ideal, especially when you want to eliminate false positives. The other type of thing you can do is abstract syntax trees, right? Now, abstract syntax trees typically is where your code is a tree. And code is, in fact, when you are in your IDE, your code is essentially represented as a tree. And you have functions, you have your global variables, your local variables, you have your entire whatever is in your code is represented as a tree, and your static analysis tool analyzes it as a tree. So it analyzes function calls, it analyzes arguments to these functions, it analyzes all of that stuff, and it essentially comes out with the findings based on whatever it finds. So, for instance, let us say this is a very popular JWT bug. So, for instance, I have a JSON web token that I want to validate. So this is a Python example with JSON Web Token. If I want to validate a JSON Web Token with Python, I will first look for the library jwt.decode, the function call from the module jwt.decode, and then I would look for a argument called verify. If that argument is set to false, then we have a flaw. That is obviously, that means that somebody could bypass authorization quite easily on your own because it's not validating a signature at all. So that's essentially what an AST can do. Now, most of your tools, especially special purpose tools, the one I'm talking about here, are those kind of tools, right? So they typically are able to do AST. Of course, even the commercial ones do AST. I'm not saying that they don't, but for some languages they do AST, and some languages they might do a little bit of regex. But commercial tools and or open source tools, especially specific language tools, do AST-based analysis. Now, this is good because they're a lot more accurate. They're usually a lot more lightweight as well. And since they are single language and single platform, they're also a little bit more focused on that particular thing. Of course, if you want very large coverage across, they don't do as much of a job as maybe a commercial tool does. And in many cases, they don't do the whole sync and source analysis, which means that they don't check which different locations in which that particular variable is being called, which might render it vulnerable or something like that, right? So they don't do sync and source analysis. Most of these open source tools, at least. So they just look at a file, they read it line by line. Of course, they do tree representation and they go through the tree based on the rules, and then they would come out with some kind of analysis. Now, a very popular tool in that class, let me just excuse me a little bit. Sorry about that. A very popular tool in that class, especially for Python, is Bandit, right? You have different tools for different things. So if you look at Bandit, I think this is the latest one. So Bandit is one of those tools for Python. I use this a lot. A lot of Python folks really swear by Bandit. It's great, right? And this is one of the types of tools that are out there. There's another one called Brakeman, which has been around for a while. In fact, we talk about a lot of these tools in our DevSecOps class, and you look at automation possibilities and all that stuff. So Brakeman is another tool. Now, all of these tools are typically AST tools, right? So what they do is they break down the source code into syntax trees. They have a bunch of rules. They run these rules against the code, and then they identify security issues. Now, this is in stark contrast to the regex approach, where you write a regex, but again, you might have written a not so very good regex, or let's say you have a code comment like this, then your reject trips even on a false positive. And let's say this is a million lines of code kind of repository, then obviously you're going to be running into huge number of false positives, which is a big problem. So this is something that you should keep in mind, especially when you deal with regex versus abstract syntax trees. Now, recently, like I said, I came across something that was really interesting, and I found this to be very, very nice, which essentially are semantic grep or code querying type of tools, right? So GitHub kind of made this a little popular with their acquisition of Semel, and I think they renamed it and called it CodeQL. In fact, let me just pull up the link here. So GitHub allows you to query code like you would query SQL. I'm just going to post the links on the stream. So this is GitHub's CodeQL, and this has been around. In fact, it used to be called SemelQL, but now it's called CodeQL. I think GitHub, once they acquired it, decided to call it CodeQL. So one of the things that you can do with CodeQL or SemelQL or whatever you want to call it is that you can query for patterns like this, right? So based on certain patterns, you can query code just like you would query a database, and that would give you a massive amount of insight into this code base, simply because you are still doing a grep like thing. While this is not grep, it's a query. You're querying for patterns in a past syntax tree is what I'm guessing. I'm not 100% sure as to what they're doing, but I'm guessing that that's what's happening behind the scenes, where you are essentially querying for these patterns, and based on these patterns, you're able to find security flaws, right? So you're able to find all of these security flaws. So in this case, you see that you can query from this data flow, you identify this, and then if it triggers this, then you call this an unsafe deserialization or insecure deserialization. You classify that as a vulnerability. The other tool that I saw recently was called Semgrep, and this was something I'm going to be talking about now. Semgrep, is something I've just gotten to know very recently. About, like I said, about 2 weeks ago when I spoke at OWASP Seattle, I started checking out the project, and I really liked it in the sense that it's so cool, because I found CodeQL a little hard to use, right? So CodeQL is great, but I still find that a little daunting to use, especially one, because I hate SQL, and this kind of gives me all the typical issues that SQL does. So the idea behind Semgrep is that you don't need to, it's still doing an AST or a semantic search on your source code, but instead of you using queries and all of that complicated stuff, you are actually using regex like patterns, right? So regex like patterns like this. So for instance, if you want to have variables, you can do the dollar variable, and then you can look for that. Or if you want to check, so let's say you want to check whether somebody's made an HTTP request and turned off SSL verification. Let me just increase my screen. Turned off SSL verification, then you can check for this. You can say request.get ... which essentially implies that there are other arguments, or there may be other variables in there, and then other variables that are preceding it and succeeding it maybe. But you are looking for this pattern where verify is equal to false. And if that's verify is equal to false, it means that they're not doing any kind of TLS verification of that particular line of code. As a result, you can trip a rule, right? The cool thing is that you can write these essentially lightweight rules, and it's really lightweight to come up with these rules, and you can load that into one rule dictionary of sort, right? And they also, the one thing that I really like is they have a pretty large repository of rules for different languages that they support, which is kind of nice. And they support these languages. I have not personally checked out its efficacy on these languages, but I definitely have done some experimentation on Python, and I find that to be pretty awesome. So I have no reason to believe that this would be bad. So again, I've not checked this out, but definitely I've done some work in Python, and that's what I'm going to be showcasing today. So Semgrep is open source. I think they do have a commercial version. I'm not 100% sure. But definitely the one that we're going to be looking at is the open source version. They also have a nice little IDE like environment where you can run these rules and identify whether whether you can trip certain patterns, and you can learn a little bit about Semgrep. So let's actually get down and dirty. Let's look at some code. Let's stop talking about what it can do and actually look at what it can do. So I'm going to write some Python code. I'm going to write it, and I'm going to call this app.py. So I want to introduce some authorization flaws in JWT, specifically with JWT. So let me just, I'm going to paste some links here so that people can probably get some information about these specific vulnerabilities that we have. So I'm just going to just give me a sec, paste this link. So yeah, so this is some of the stuff that we're going to be looking at. So let's get started. Now, in this example, what I'm going to do is I'm going to write some code that is going to, so imagine that this is a web application and I want to verify a token. So essentially, it's accepting a JWT or a JSON web token, and obviously post verification of whether that token actually is right or wrong, or whether it's the signature is valid or not. I want to be able to authorize that user to access my application. So that's what I'm doing here. So what I'm going to do is I'm going to import JWT, and then I'm going to start up a function saying accept request. So let's say I have this function called accept request. And then what I'm going to do when I start accept request is I'm going to decode the token. So this is JWT. I think I'm going to just reduce the screen resolution a little bit. So JWT.decode, I'm going to decode the token that comes in. So just say I'm going to decode the token, and I'm going to decode it with a password called password. And I am going to set the verify is equal to false, just like our AST example before. So you can see what's happening here. The token is being decoded, but I am not verifying the signature of the token. Right? So this is obviously bad, because which means that anybody with any token can just randomly send you tokens, and if it's a JWT, it's just going to decode it, and you have a massive authorization bypass issue, and you don't really have an authorization system at that point, right? So it's a huge problem. So let's try and find this with a Semgrep rule, right? So I'm going to open up a new terminal, and just going to, just keep it here. So what I'm going to do is I'm going to say semgrep -e. Let me just do the lang thing first. So I'm going to say, hey, this is Python, which means that, remember, Semgrep is not just blindly doing a grep, right? What it's doing a semantic. So it has obviously some Python understanding built in. It obviously has an AST library under the hood that probably parses the Python code as a tree. And then based on the rules you give it, it's able to convert that into a rule definition against the AST and find that particular pattern. So that's typically how I think it is working. So let's write a rule that says jwt.decode. So I'm saying that, hey, whenever you look at jwt.decode, look for this. It can have, of course, any arguments that you want, but only if this argument, which is verify, is set to false, and of course it can be preceded by any argument, only then you need to trigger this rule, app dot. And you see that it found this on line number 5. So it's pretty quick. And in fact, I've run it against a pretty large code base as well. It's pretty fast. It's not obviously this is one line of code, but over time, you can see that it's pretty fast. It's able to actually find these kind of patterns pretty quick. Now, one of the things that I've also run into with a lot of AST libraries is that with Python and many languages, you can start aliasing stuff, right? So let's say if I do import JWT as tokenizer, horrible name, but nevertheless, a tokenizer, right? So let's call this tokenizer. Now, if I had a AST tool or a static analysis tool, it would obviously look for this module and this function. So since I've imported it as tokenizer and I do tokenizer.decode, it would not trip against this particular rule. But with Semgrep, if I actually do the same thing, it recognizes that JWT is the actual module. It may be aliased, but that's still the module. And if I run it, you'll still see, oh, I didn't save it, sorry about that. You'll still see that it finds that, hey, this is still an issue with your code. So it's able to actually semantically understand. It's able to cut through that whole aliasing challenge that some of these languages have, especially with Python. This is a big thing. In fact, I've seen developers actively evade static analysis checks by aliasing stuff, right? So this is something that is pretty interesting that you can do with Semgrep. Now let's look at another case, right? So let's take another example of what you can do. And what I'm going to do now is, instead of doing this kind of CLI REPL type of thing, I'm going to write a rule dictionary of sorts for Semgrep. And you can do that with a YAML. So I'm a big YAML fan, although I know a lot of people hate YAML with a deep amount of hatred. But I really like YAML because I find that you're able to express stuff pretty easily versus doing stuff like JSON. So I'm going to open up a small YAML rule file. So I'm going to say jot rules.yml, right? So I'm going to just start the rules. So I'm going to say rules. This is Semgrep allows you to write rules like this. So I'm going to say JWT verify false, right? And this is going to, as if this is triggered, it's going to throw a message saying JWT library set to verify is equal to false. This is an auth bypass attack, auth bypass vulnerability. Okay, so just saying a message, whatever message that you have. Of course, I can also, I need to set which lang it belongs to. I think it is lang or languages. I am not 100% sure. Just let me check back in the stuff that I've actually already written. Just give me a sec. Languages, sorry about that. Languages. I don't remember this off the top of my head. So it's a Python thing, and I want to set the severity to error. I'm not sure which specific severity level they support. I know they support warning and error, but I'm not sure if they support anything else. So now I'm going to write my patterns, right? So remember, this pattern is going to show up inside a function. So I'm only looking for this pattern inside a function and not outside. I'm not looking for it as a global variable kind of thing. So the first thing I'm going to do is write out patterns, right? So I'm going to say pattern, and the first thing I specify is pattern inside, which means that say that if you want to look for this pattern inside a module or inside a function, you can use the definition pattern inside. And this is all in their documents. I kind of went through this. This is not with just a basic perusal. I was able to find some of these things. So pattern inside, and I say that always the pattern is inside some kind of a function. So it's always in a function, right? And I essentially say that it's in a function, and the function could have whatever other stuff. So the dot 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 is essentially going to be a placeholder for saying that, hey, there are other things, or there are other arguments, or there are other variables in here. You don't need to look at that. Focus on the construct that's actually in there. So in this case, it's looking for it inside a function. So what I'm also going to do is I'm going to start writing out my pattern. So pattern, I'm going to use either you can use a pattern either when you want to specify multiple patterns. In this case, I'm just going to specify a single pattern, and I'm going to say jwt.decode dot dot dot, same thing, verify is equal to false dot dot dot, right? So this is the first thing I'm going to do, and we are going to run the YAML, right? So we're going to run our Semgrep with this YAML as the configuration, right? So semgrep-f, which is the configuration directive, JWT rules, and I'm going to run it against app.py, and you see that it found this error. Obviously, it tripped this rule, just like we saw before, tokenizer.decode, we have a problem. Now, this is great, as you can see, because I can create a nice little dictionary of rules and run it as part of my CI/CD pipeline, and it is pretty fast. As a result, what you will see is that since I can run it as part of my CI/CD pipeline, I'm going to be able to actually get a lot of value from running this in a repeatable way. And the cool thing is I can actually customize it to my environment, right? So I don't, let's say I'm just building a Python app with no, let's say I'm not looking at any other rules. I'm just looking for specific stuff for Flask or JWT and stuff like that. I don't want it to fire all kinds of rules. I want it to fire a very specific subset of rules. So I can actually build out that rule dictionary and fire that. So let's look at another pattern and let's see what we do here. So I'm just going to go back, not call this tokenizer anymore, which is a horrible name to begin with. I'm going to call this just JWT. Now the next thing, I'm going to also remove the, in fact, let's open up another function. In fact, let's do that. So accept another request. Okay. So here I'm going to say decode jwt.decode. I'm not going to make the same mistake that I did here, but I'm going to make another mistake. And I'm going to say token and password. Now in this case, I don't know if anyone watching has figured out what the issue with this thing is. Anyone wants to hazard a guess, you can post in the comments on YouTube. You should, if anyone knows what is the mistake I'm making here. Any idea? All right, looks like nobody has responded. Of course, so this is a possibility of a algorithm confusion attack. So here, remember, usually what I would have to do is I would have to declare the algorithms that I am verifying this token with, right? So which means that I'm verifying this with an HVAC token or HVAC password, right? So in this case, I specify the algorithms, and then I'm going to be able to verify it against those algorithms, which means that it would check against that algorithm, check whether it's an HVAC, and then use this password to generate an HVAC, and then check it against the JOT that comes in. Now this is, so if I remove this, it means that somebody could send me a algorithm or a token that has been forged in a different algorithm. This is typically called an algorithm confusion attack, where the attacker uses a RSA public key as an HMAC key and sends it across. So essentially confusing your system. And if your application does not verify the specific or does not mandate the use of a specific algorithm to verify the token, you have a flaw. So let's look at this. This is an example of an anti-pattern or a negative rule, right? So in this case, we are not looking for things that are in there. We are looking for something that is not in here, right? So ideally, we should have had another parameter or another argument here called algorithms, which is not there in this case. So what I'm going to do is add another pattern. Now, the next thing I'm going to do is say pattern, or actually, let's define another rule. Right. I'm just going to, yeah. So in this case, I'll go confusion. Yeah. So in this case, what I'm going to do is JWT library does not, JWT decode does not specify algorithm to be used. Only when you do live demos that you have butterfingers. It's horrible. Anyway, so again, this pattern is also going to be invoked always inside a function. It's not going to be invoked outside a function. So what I'm going to do is I'm going to write up my pattern. So in this case, what I'm going to do is say ... So in this case, what I will have to do is a little different. I'm not going to say pattern either. I'm going to say pattern not. So which means that look for something that is not here or may not be here. And if it's not here, then we have a problem, right? So I say pattern not, I do jwt.decode algorithms ... and then comma ... So I'm saying that any argument could be here, any argument could be here, whatever. Algorithms, you need to have a argument called algorithms, which is a list type, which could have any arguments in there. So that's essentially what I'm trying to do. So if it does not find the algorithm parameter being declared here as an argument, it's going to trip that rule and say, hey, this is a problem. Right. So I'm going to run this again the same way I ran the previous one. When I do this, you will see that it trips two issues at this point in time. So the first one, it says algo confusion. We have not specified the algorithm. Actually, that was another thing here as well. I not specified the algorithm here as well. So it's actually the right finding. And you see that it's found the verify false only on that rule, which is actually very, very useful. And I'm able to actually identify this. In fact, one of the cool things that you can do is you can also get this entire result in JSON. Right. So in JSON, the cool thing with JSON is that if you're running it, especially you want to pass this result and push it into a vulnerability management system. So let's say you're using something like Orchestron, which is something that we've built, which is a vulnerability management and correlation system. You want to push this result into Orchestron, you should be able to do that when you have a JSON result, which is really, really cool. Now, one of my common beefs with a lot of static analysis tools is that they just don't give you enough data or taxonomy related data, right? So they don't tell you. One of the things that I really would like my static analysis tools to give me is taxonomy related data. And when I say taxonomy related data, what I mean is the CWE. Now, the CWE is very important to me. The reason it's very important to me is that it's a common weakness ID or common weakness enumeration ID. Now, by looking at a CWE, I am going to be able to say that this belongs to a particular class of law, right? Now, CWE is very important. That's how tools essentially. So, for instance, in Orchestron, one of the things we do is try and correlate by CWE. So, if ZAP has found a SQL injection and Semgrep has found a SQL injection, they both are SQL injection, right? So, they should be represented as a SQL injection, and that's what you want to do. And one of the ways you do that is, of course, with the CWE. And most tools, especially open source tools, I find them incredibly guilty of this. Is that they do not ever give you a CWE value, which is, I don't know why they do that. It's horrible, but they do that. And this is something I really would like. In fact, you have CWEs for a lot of tools. Zap, for instance, gives you a CWE. Most commercial tools give you a CWE. But for some reason, a lot of open source static analysis tools just don't seem to care about CWE, which is something that I've always held against them. Now, let us say I want to add CWE to my Semgrep rule set. So the first thing I want to do is I can add a metadata object. So which is really cool. I really like this in Semgrep, where you can add something called your own metadata object, and I can specify this as a CWE. So let's say I want to look up the CWE for this. So let's look up CWE for authorization bypass. This may not be exactly correct. So let's say 285. Yeah, this probably looks about right. Yeah, so yeah, when access control checks are not applied consistently. So yeah, generically, probably this could be set up as CWE 285. Now, algo confusion is probably, it's again causes CWE and authorization bypass, but probably through some other means. So let's see whether incorrect authorization or something like that, right? Yeah, so maybe this. Let's cast it to this ID CWE 863. Now the cool thing is when you use the metadata key, you can actually set up your own metadata information. So if you want a bunch of fields under that, you can actually do that with Semgrep and set this up. So now when I run Semgrep and I output the data set in JSON, you will actually see that the CWE is also reported as part of that. So you see CWE 285, CWE 863 are both reported, which is really, really nice, right? I really appreciate the fact that they've been able to they've incorporated this into their design. I think it was not part of their initial thing, but I think about a few days ago is when I think they incorporated it, and I'm really happy that they did that. It's an awesome thing to do. I think you can add some additional fields like fix and so on, but I really like what they've done with this. So the idea behind Semgrep is that you should be able to do all of this stuff and more against a pretty large code base. So let me actually show you. So this is a lab I recently wrote with Semgrep 2 days ago against for our DevSecOps class. I'm going to show you this lab quickly and just show you how that works. Just give me a second. Yeah, so I have two code bases here. So I have two code bases. Again, I have a Django app and I have some Flask app here, which I had some. So in the Flask app, I want to look for the JWT thing. You already saw this. But I also want to look for template injection, right? So Ginger 2 that Flask uses could be vulnerable to template injection. I've also managed CW for that, CW for this. And I'm also looking for whether they've used MD5 SHA-1 or something like that. So when I want to run this, it's really cool. I'm running it against my code base, which is here, which is this vulnerable Flask app. and I can run this. So that's going to be Semgrep. This would be Flask. And then, of course, let's say vulnerable Flask app. So you see that it's able to find all of the security rules that it trips, right? So you see that it's using MD5, which is a problem. It's using render template string, which is going to cause a template injection flaw. So you can see that we've been able to get pretty up and running with this right off the bat. And the barrier of entry, especially from a learning perspective, is definitely lower because you don't have to sit and worry about all of that the complicated AST. So if you need to write AST libraries or AST plugins, believe me, it's not easy to do that. You need to understand quite a bit. So the barrier of entry for doing that kind of work is a lot more. So I would say that this has significantly, at least from my perspective, made it a lot easier for me to be able to do this. So in this case, you see that I was able to find a bunch of SQL injection bugs. I was able to find a deserialization bug. You can do this at scale, which is pretty really, really cool with Semgrep. So that brings us to the end of our live stream today. If there are any questions, I'll be happy to take them. Of course, if you want more such things, you want to shoot a question online, just follow me on Twitter at Abhay Bhargav. So this is going to be Twitter, or if you want to follow the company as well as myself, you can follow what we do. We do some pretty interesting stuff all through the year. So you can follow us on Twitter. Of course, look us up on LinkedIn. You want to write to us, write to us. Again, as always, we're running a bunch of awesome trainings, and these trainings have been featured 5-on-5, 5-star trainings at places like Black Hat and all that stuff. If you want to register for any of our trainings, go to store.v45.com. Find the DevSecOps training and the containers training are really hot and happening right now. You want to look at it, and let's get started with a lot of this stuff. Thank you very much for attending. Thanks for being a part of this live stream, and I'll see you next week with a different topic. Thanks very much.